now we talk about the bioassay for Spinosad. This is a relatively new pesticide under US EPA. It belongs to reduced risk pesticide. So a lot of formulation registered for agricultural use. Some product is registered for mosquito control recently. So the material, first of all, we're using is this fine sand granules, or whitish granules. It was 2.5% spinosad, actually 85% of spinosad A and 15% spinosad B, spinosad D. So these granules, you're still gonna do just like a BTI, sterile dilution. You're gonna make a 1%, but remember this is based on a product, not the AI level. So after you got your final results, you have to convert to the AI level. But it doesn't matter as long as you compare it under the same standard, product concentration or AI concentration. So to make a dilution for this material, we're still using the same 10 times dilution. And you still start from 20 ml of 1%. Not always like this. If something active ingredient level is so low, you don't want to start from a very low amount. You want to start fairly larger amount and make a larger volume, and then you dilute down from there. Otherwise, you're gonna have an error because this concentration is so low. So you add this 20-18-18. This material compared with BTI WDG we mentioned earlier is a little bit more challenging to suspend because it's a firm sand granules. It take you some minute to suspend, but you do want to make sure the finished point is you see the clean sand down to the bottom. The water can become whitish, like suspension looking. But when it's the finished point, you have to see the clean sand down to the bottom. There's nothing coat on it. Basically, this formulation is made of sand as a core, then the coating materials over it, containing 2.5% spinosad by weight. So for video purpose, I'm gonna assume that my shaking is enough, but actually not. But during the actual process of bioassay, you do want to make sure that the sand wash is thoroughly clean, meaning all the materials are suspended in water. So from here, you make your sterile dilution just same as we did for BTI early. So you want to make sure your calibration here is the amount you intended for. Every time you shake before you take. So how do you decide this concentration range? It's also based on experience, early work. This is the range for most of the mosquito collections. You're gonna have a 5 to 95% mortality. This is the concentration of 0.01% of 2.5% natural or G30, one of the sand granule formulations of Spinosad. When you're done with the material, so you prepare your orby, and still we use 4 concentrations from the low to higher than medium, then higher, then the last one is your untreated control. You always have untreated control, otherwise cannot validate data. So add 100 ml water. When you add 25 larvae, use the screen to minimize any, you don't want to hurt the larvae or traumatize the larvae. Then make 25 per 100 ml water. You use anywhere from 3rd instar to early 4th would be fine, because Spinosad is a neurotoxin. It does allow you to have a little broader instar or age range. And then you make your treatment. The concentration we're using is 0.1, 0.25, 0.5, and the 1 parts per million of 2.5% product. And untreated control. So you get all water and larvae going, and you make a treatment. The calculation is simple math. For the first one, you want to achieve 100 parts per million. What you need to do is, to this 100 ml water, you add 0.1 ml of 0.001%. Your final concentration is 0.1 parts per million. So once again, this concentration is based on the product. So when you, after you read the results, when you report LC50 or LC90, you need to convert to active ingredient level. So that's pretty much for the setting. Of course, last thing is the same thing. You want to add some food, and not too much, like 10% rabbit pellet suspension, a couple of 3 drops, for the reason of the larvae need to feed, and the Spinosad is by ingestion and QQ absorption in order to kill the larvae. So ingestion is the primary way. They need to ensure the larvae is feeding actively in order to get enough Spinosad. Of course, you don't want to add too much either, because when you get too much food in the warm temperature, the water will turn to murky, it will form a scum on the top, and then you're going to have some additional larval mortality, which is not caused by Spinosad, instead it's caused by water quality issue. So this should be typically what it looks like after you treat. So for this material, the exposure time also 24 hours, just like BTI, under warm temperature 82 to 84, and by then you're ready to read larval mortality at your results. So as in BTI, the exposure time for Spinosad also 24 hours under warm temperature. So day 1 acceptable test, day 2 you rate, and first you take a look from your lowest concentration, then the higher, then medium, then very high, and versus the untreated control. So what you should see is, you see a range of concentration response. Basically, the first row you should see barely any dead ones, if you can find 1 or 2, and then you will see more dead ones, and even more. Then the last one you should see very few survivors, and most of them should be already dead. And untreated control, you should not see much mortality at all. And you have to look hard, and you're looking for any dead ones here. From my test, I can tell I don't have any dead ones here. You can control for the short-term test, like 1 day. You can pretty much handle the quality, like 0 larval mortality in untreated control, which is really good. But I normally allow to 5%. If above 5%, I even do a correction or redo the test. So Spinosad is different from BTI. We know BTI is the gut toxin. Spinosad actually is the neurotoxin. It's a acetylcholine receptor agonist to stimulate acetylcholine receptor in competition with acetylcholine, and to excite the larvae. So the larvae get overexcited, and then, well, you can't be overexcited for too long. You're gonna mess up, and they're gonna cause paralysis, and then the larvae gonna die. So That's why if you start here, the larvae, you can see some larvae actually they're shaking, just like intoxicated by drug, just like that. They're shaking around, they're dying but not quite dead. The tricky part for Spinosad is as a neurotoxin is if you don't stimulate the larvae, they give you an impression that they look dead, but because they're exhausted, they don't move much. Their body look a little weird, but they're not dead at all. They just exhausted. They want to take a break. So when you stir up the water, you can see they respond to your disturbance quite well. And then all of a sudden they're diving around gracefully. Looks like no treatment even. So the results reading in Spinosad is a little bit trickier than BTI. It's still the same principle. You're gonna read from entry to control. Entry to control first because it's clean. Then you move to the lowest concentration, then the second and third, and lastly, you read the highest concentration. The same thing as in BTI. You count the survivors. You disturb this, blow some air, disturb this, then you count the survivors, not the cadaver, not the dead ones, because the dead ones often will be eaten as a food by the survivors, then give you a wrong rating. And we have the same issue as moribund larvae, particularly for Spinosad, this neurotoxin. And some larvae, they're dying, not quite dead. So you have to make your call. You count those ones as dead. And sometimes you have to blow a couple, 3 times to make sure is that one moribund or normal. Because dead is a status, dying is the process. So sometimes it can be a little tricky. So after this, you record your number of dead ones versus number exposed, of course 25 per cup. Then you put your raw data in this paper. Same as BT, I give you a quick estimate if on this paper when mortality turned to per unit, when concentration at the log scale, if you see the dust line up, pretty much tell you that the test is quite good. And also you see the distribution of the dust. In the first one, the lowest concentration should have around 5% plus minus 10 or 15, still okay. The high should be 85, 90, 95. You have a good coverage. On the other hand, if you see your data, dust are jump around, you may have to redo it because the computer is a computer. Computer will take numbers. If it doesn't like the numbers, it will refuse to give you results or give you results like very, very broad confidential interval. You can't use it sometimes, particularly for publication purpose. That's pretty much how we read the results for Spinosad. Some similarities, but some differences versus BTI.